Hey, what's up you guys, it is Harrison and welcome to School of Swag. So today we're going to be talking about graphing in the Argand diagram. This is the fourth video in a series of videos talking about complex numbers. So I'll put in the link in the description to the rest of the videos so you can go check those out. So yeah, let's just jump right into it. So hang on, before we get into it, there's going to be two parts to this particular video, because one part I'm just going to be talking about the concept, and the next video I'll be talking about some specific examples. So let's just get into it. So this graphing for complex numbers is slightly different from graphing in general. Usually when you graph, you just graph a line, and a line means a line, and you know, equation is this is it, this is the equation. So but when you're talking about complex numbers, what we're graphing here is actually loci. Loci means like we are given incomplete information, so we don't have instead of like this is the point right here, this is the point, we have, you know, this line represents possibilities that the point could be. So I hope that makes sense. It's like we're given an incomplete picture of where this point could be, and using the information that we have, we just draw a loci. So that's basically what loci means. So in the A-level syllabus, not sure about IB syllabus, but I think it should be the same. There are three types of loci that we need to learn how to graph. So the first one is it just takes the shape of a circle, and the equation, it looks like this. So I just need to explain what this means. So when you see this, okay, I'll just talk about it in the next slide, but the equation looks like that, and the graph is a circle center A with radius r. So so don't be fooled by the modular sign, because the modular sign may not guarantee that it means a circle. So you see A and we see r. So you see a circle center A and radius r. Okay, so when you see a perpendicular bisector, it is different from a circle. You see two of these modulus things next to each other, equals to each other. So we have a perpendicular bisector of the 2 points A and B. And yeah, this is easy to explain what it looks like. This is easy to explain how it looks like. This one you kind of have to draw it out, and I'll show you what it looks like. A line that makes an angle theta with point A. Okay, yeah, it's just harder. It's just easier when you see it for yourself. Okay, so why? Just now I said something like, just because it's a modulus, it can't guarantee that you're gonna get a circle. So I'm just gonna show you how to read it in a way that sort of makes sense. So so when I see modulus, which is like the two vertical lines, I read it as distance from. And when I see a negative sign and A, which is a constant, I say from point A. So when I see something like that, it says the distance from Z to point A is R. And if I see something like Z plus A is R, what you have to do is change it to the proper form, which is Z minus negative A equals R. So I would say the distance from Z to the point negative A is R. So I always have to change it to the form of Z minus something. Okay, so here's how it looks when we're talking about perpendicular bisectors. So we have, again, modulus means the distance. So the distance from Z to point A is equal to the distance from Z to point B. So if you phrase it differently, you have Z is equidistant from point A to point B. So you'll see later why. Okay, if I'll draw it here right now. So let's say we have point A and point B, and I'm just gonna draw, and this is the midpoint between A and B. So we can see if Z lies right in the middle between A and B, the distance between Z and A and Z and B are equal, right? But why not I extend this line so that it is now perpendicular to the line connecting A and B. So if Z is here, but by Pythagoras theorem, there's this line. Okay, or you can just eyeball it. So if Z lies anywhere along this line, then the distance from Z to point A is equal to the distance from Z from point B. So that is why when you see like two modular signs equal to each other, you must think that this is a perpendicular bisector. Okay, so finally, argument means the angle it makes with the line parallel to the x-axis. So by default, argument means, you know, the the counterclockwise line starting from the horizontal axis, right? So something like that means, oh shoot. Okay, so something like that means starting from the point 2, 1. Let's say this is the point 2, 1. And this is the horizontal axis. It makes an argument of pi over 4. It's not as hard as it sounds. Okay, so let's just get into some more concrete examples. So when you see this graphing of when it takes the form of a circle, it looks like this. So what you need to do is break it down. So we have our formula, which is z minus a equals to r, right? So in this case, a is 1 plus 3i. So 1 plus 3i, you know, in the form of coordinates is 1, 3. And what is r? R is 3. So center at 1, 3, the radius is 3. So you kind of need to know that. So here we have our center 1, 3, and the radius is 3. So when you are graphing this in the exams, you have to take note of the little things. So so maybe something here, something is 1, 3. So if the radius is 3, this has to be 1, 6. And if this is 1, 3, if the center is 1, 3, this has to be 1, 0. So you need to graph it in such a way that you can see it makes a tangent with the horizontal axis. So another example of little things that you need to be careful of is like this. So as you can see, this is -3 and +4, and the radius is 5. So you should know by now 3 square plus 4 square square root actually gives you 5. So what that means is that if you draw a diagonal line towards the origin, it should cut the origin. So it is important to check if there are these special points. Usually it is if they cut one of the vertical or horizontal axis, because the center and the radius, the coordinates matches, or you have to check if diagonally is going to cut the origin. So generally these are something that I'll watch out for, and something, you know, an important thing to take note of. So okay, let's talk about, okay, I'm gonna skip this. Let's talk about perpendicular bisectors. So what it looks like is z minus this equals to z minus this. So from here and here, we can just change that into sort of x and y coordinates. So what you need to do is plot out where 5, 6 is. This is 5, 6. And you need to plot out where it's 10, 2, which is right here. So what I would do is plot these 2 points first, and then I would draw the line that intersects them, that connects them, and then I would measure 90 degrees, and then I would draw this perpendicular line. So one thing that you need to know is you need to show that this is a dotted line. Dotted lines means I'm just drawing it to show you that this line connects, but I'm not really telling you that this is Z. That's not the loci of Z. So dotted lines means not, because it's not the loci. So when I'm actually drawing the loci, which is this, I do draw a solid line. So yeah, perpendicular sign, it is important to draw. Yeah, just take note of all these little details. Okay, so yeah, finally we're gonna be talking about graphing with argument Z. So let's talk about this. When you see something like this, again, it's argument of z minus a equals to theta this time. So what's a? A is 2 plus 1. 2 plus I, and the start point is 2, 1. So what we do is plot 2, 1 right here. Okay, ignore these points, it's part of the graphing that software I use. So, and the next thing we need to see is pi over 4. So pi over 4 is this angle. So the first thing I would do is put this point. The second thing I would do is draw this horizontal line. The third thing I do is, you know, use a protractor and write pi over 4 and measure pi over 4, and the last thing I do is just draw this line. Okay, Yeah, and it's not that hard, is it? So a few things to note. This thing has to be oh man, it needs to be a blank circle to show that you're not actually, the loci doesn't include the point itself, the point 21 itself. You also need to put like dotted lines, because the dotted lines represent that, you know, this line is not the loci, it's not what we're talking about. And yeah, you don't need to put your angle, which is pi over 4. So again, all these details, stuff that you need to know. Okay, and that's actually all for this video. In the next video, I'll be talking more about the examples that I skipped over in this slide, because I really don't want to make this video too long. And you know, if there's anything that you find that I could have explained better, or some other topics that you want me to talk about in my other videos, just leave a comment down below. I'll be happy to answer your questions and just make more topics about stuff that you guys are interested in. So you know, that's all for this video. Thank you guys so much for watching. If you like it or found it useful, leave a like, subscribe, and yeah, I'll see you guys in the next video. Bye.